Yeah. So usually nearby the exam, yeah, I mean until CSIR net exam, I have planned to solve this MCQs. Okay. Uh, Wait a second. Huh. So can you hear me on Google? Speak up.
Yes, sir.
The plan is, I mean, I wish to pick the problem, okay, in such a way that which covers, I mean, which touches different topics, okay, speak up. So that, I mean, many previous students are there here. So it will be very good revision for them, okay, speak up. Sometimes I may pick some easy question, some very difficult question also, but I'm going to pick the question according to revision, okay, speak up. I mean, we should able to touch various concept, okay, so that I can explain little bit in every problem, so that many concepts are touched here, okay, speak up. So I mean those who haven't done our course, okay, I mean you may feel little bit difficult, okay, but anyway I'm going to what you call try, I mean I'll try my best to convince the I mean concept roughly, and then move on to the what you call complete solution, okay, speaker. So here we shall start with electronics, because in our course, I mean in our ongoing course we were doing electronics, okay. I'll start with electronics, okay, I mean analog electronics, okay. So then some digital electronics and all. So what I did today is I picked very I mean easy to moderate level question, okay. Tomorrow I'll pick some challenging to even controversial question, okay, like I mean where options are bit controversial, okay, speak up like that. I mean in CSIR net, in old CSIR net there were many mistakes actually, okay, but in the recent question paper they are avoiding those mistakes. I mean I think less or no mistakes, okay. So but when we start solving previous CSIR net paper, sometimes we will stuck somewhere because questions are not well designed, options are not well set and all, okay. So anyway, right now it's not time to think of that one, okay. And one more thing is I don't what you call prepare, okay, students just by thinking previous paper or something, okay, speak up. Previous CSR net paper, it was quite tough, okay, and I mean we can't expect the same paper this time, okay. I mean we can expect maybe more tough paper or maybe easier paper, maybe gate type of paper or just a type of paper, or like CSR net paper, like I mean some previous question repeated, I mean that pattern actually, okay, speak up. So that pattern need not to repeat actually, okay, speak up. They can change the pattern anytime. I mean you can't say that after the exam, okay, they change the pattern or they give very different question, they didn't give this question. You can't say like that, am I right? So that's why let us not prepare, or let us not have this what you call revision or problem solving session by keeping only one last exam concern, okay. And I'm going to solve previous last exam questions also. On Google Meet, someone mic is on. So Shaktivel, can you hear me? Yeah. So that's why it's not a good strategy. Okay. I mean there are no strategies actually. Okay. In the exam hall only, you need to strategize and you need to pick the proper questions and you need to solve and you have to maximize your score actually. Okay. I mean we can't predict now. I mean whether question paper is going to be like last CSIR net, where questions are quite deep, okay, or before that questions are not so deep, but I mean very quite easy. I mean cutoff went still high like that, okay. I mean we can't predict that one, okay, speak up. So I mean I have already seen the what you call adverse effect of predicting the question paper and preparing, okay, speak up. I mean so there were some student who kept the syllabus and what you call syllabus of exam, okay, previous question paper, and prepared for years of time. Then in that year, I mean they just changed, I mean they didn't ask usual question. I mean then what will happen? The whole effort will be wasted, am I right? That's why you should be ready for anything, okay. So what I suggest is just a head down, develop your skill, problem solving skill, okay, expand your what you call syllabus, okay, so that in the exam hall you will have a choice. You can leave difficult question, you can choose easy question, okay. And so develop your conceptual knowledge, problem solving skill, okay, and practice, okay, pick up. I mean without or any mistake, you should be able to solve the problem. Okay, so with that, okay, let me move on to this one. Okay, I have picked some very easy question. I think I have posted in Slack workspace. Okay, speak up. So let me start with, suppose, let me think of the syllabus. Okay, and then I will pick the question. Okay, whatever syllabus we have, then I'll pick the question. Okay, speak up. Suppose if we start with simply diodes related question. Okay, I picked CSIR net question only. Okay, speak up. So in the circuit below, D1 and D2 are two silicon diodes. Okay, whenever they say silicon diode, speak up. If they say silicon diode, there will be forward characteristic, reverse characteristic. Am I right? Speak up. uh, so where current, voltage across the diode. Okay, speak up. So you should know what is the equivalent configuration. If you draw equivalent configuration, it's nothing actually. Whenever you have any circuit, okay, if you draw that equivalent configuration, diode circuit, the problem is nothing actually. Okay, for those who don't remember the concept, okay, in the forward characteristic, okay, we draw like this. Okay, for silicon diode, so this is 0.7 volt. Okay, if the supply is not, what you call, making it enough forward bias, okay, it is acting like a open actually. Okay, pick up. Let us see in the reverse bias. Okay, it will be like this. Okay, very small current will flow, but we neglect that one. Okay, so that's why in this region, we have already discussed this one, in this region and in this region. Okay, your diode, silicon diode, must be replaced by open circuit. Can I say like this? In this region and in this region. Okay, in this region. Fine. In this region, when it is reverse bias, okay, acting like open, if it is not sufficiently forward bias, okay, speak up. If the source is less than 0.7 volt or something, then also diode should be replaced by a open. Okay, in this region, when it is sufficiently forward bias, okay, that silicon diode, it act like a tiny battery of 0.7 volt. This is P junction, this is N junction, P region, N region. Am I right? It will act like a battery like this. Fine. Of 0.7 volt, like this or reverse? Like this. Okay, yeah. So that in this region, if it is operating in this region, the diode must be replaced by 0.7 volt battery. Okay, so very similar thing follows for Zener diode also, but in CSIR net, I didn't find many question on Zener diode. Let us see the last question paper. Okay, speak up. In Zener diode, this breakdown region, okay, speak up. In that breakdown region, that Zener diode will act like a battery. Okay, speak up. So why it is considered as a battery? Because look at here, so its forward resistance is very, very low, but there will be some drop actually, isn't it? There is one potential drop across the, what you call, diode actually. Am I right? Potential difference is there, but resistance is very, very small. Okay, it is not any resistive network, it's not any ohmic material at all. Am I right? Speak up. So that's why it's better to replace silicon diode, okay, by a 0.7 volt battery when it is completely forward bias. Okay, when you see this one, this 10 volt battery is sufficient to forward bias both of these two diodes. You can just see by seeing the circuit that 10 volt battery is going to forward bias both of this. Okay, this 1 kilo ohm resistor, you can see here. Okay, so this is positive, this is ground. Am I right? Positive ground, isn't it? Speak up. So now let me draw the equivalent circuit here. Okay, very simple. Let me draw the equivalent circuit. This is our 10 volt battery. Fine. 1 kilo ohm resistor. Then this D1 is forward bias. It is acting like a battery of 0.7 volt. Fine. Speak up. D2 is also acting like a battery of 0.7 volt. Fine. And this is our V naught. Okay, he's not asking V naught. What he's asking? Value of I1. I think I1 plus ID1. Okay, he's asking like this. Okay, he took this is 1K. Okay, this is 10 volt. Speak up. This is I1 he mentioned. Okay, he mentioned ID1, ID2. Okay, speak up. Now, remember these two, what you call these two diodes are in parallel. Okay, speak up. And they are of same characteristic. I mean, they look at here, silicon diodes with the same characteristic he mentioned in the question. Okay, so that's why what you can assume is ID1 is equal to ID2 because they are connected in parallel. I mean, they will be biased in the same manner. Am I right? Speak up. Here you have a voltage source. Okay, you have one resistor here. Okay, so since they are connected in parallel, okay, they are forward biased in the same manner. Okay, speak up. So then I can assume that, okay, this ID1 is equal to ID2. Is that okay? If I assume ID1 is equal to ID2, then this I1 is equal to, speak up, I1 is equal to ID1 plus ID2. Am I right? Kirchhoff current law. I1 should be equal to, this I1 should be equal to, I mean, if it is open here, okay, so this is ID1, this is ID2. Am I right? You can see here, if you apply Kirchhoff current law, I1 is equal to ID1 plus ID2. Okay, speak up. What he's asking, I mean, he already said, okay, take it as 0.7 volt, okay, 0.7 volt here. Value of the current I1 plus ID1. Okay, now look at here. Can I write this I1 as 2 times ID1? Because ID1 and ID2 are equal. Okay, speak up. Now look into this one. If you apply Kirchhoff voltage law in this circuit, how simple it is. Only I1 comes in your Kirchhoff voltage law. This ID1 won't come because you know what is the potential drop. I mean, whatever the current that flows through the diode in the forward bias, you know what is the potential drop. Potential drop, I mean, potential difference across the diode that is stopped at nearly 0.7 volt, isn't it? Even though whatever may be the current. So that's why. So when you apply Kirchhoff voltage law here, okay, 10 volt, okay, minus what is this one? I1 into 1K, okay. What is this one? Decrease in the potential minus 0.7 volt, okay, that's equal to 0. Look at here. In this Kirchhoff voltage law, only I1 came. Even though in this arm ID1 is there, okay, that didn't appear actually. Only one unknown. You can quickly find I1, isn't it? So this is the very nice part of the diode actually. I mean, even though you don't know what is the current through it in the forward bias, you know what is the voltage across it. Okay, speak up when it is sufficiently forward bias. So that's why from this one you can find I1. What is I1? 9.3. 9.3 volt divided by 1 kilo ohm, like that. Okay, that kilo goes to above, that will become milli. Am I right? I1 is equal to 9.3 milliamps. Okay, speak up. So that I1 is equal to, speak up, that's equal to 2 times ID1. So that's why ID1 is equal to I1 by, speak up, 2. What is this one? 4.65 milliamps. Okay, I mean, he's asking, I think, quite strange thing. What he's asking? I1 plus ID1, whatever he asks. Okay, you can find this one. Okay, so that's why I1 plus ID1. What is this one? 9.3 plus 4.65 milliamps. What is this one? 13.95. Okay, 13.95 milliamps. Okay, speak up. Now I will have to actually check the answer key also. Is that right? Anyone who solved recently? Answer 3, that is right. Okay, speak up. Answer key. Fine. Speak up. You just have to know this concept, isn't it? I mean, when it is sufficiently forward biased, it's like a 0.7 volt battery. Okay, and if it is not sufficiently forward biased, also you should take it as a open. If it is reverse bias, also you should take it as open. Okay, when it is reverse bias, you should not what you call apply very high reverse voltage, so that you should not go to breakdown region. Okay, speak up ordinary diode. Okay, and one more thing. Okay, each and every sentence in the question, okay, it has a hint. Okay, speak up. Hmm? Each and every sentence. Okay, so when he said diode with the same characteristic, I mean, it is to say that ID1 is equal to ID2, isn't it? Okay, I mean, you know that it should be 0.7 volt, 0.7 volt and all. So what if at that time you get the question like, what if these currents are unequal? Am I right? Speak up. That question may appear. No, one thing is they are parallel and connected to the source. Okay, and they are forward biased in the same manner, in the same extent, and other one is they have identical same characteristic. Okay, so, I mean, that is the hint to take ID1 equal to ID2. Is that okay? Fine. Yeah, any question quickly? Anyway, let me tell you tomorrow, okay, before coming online. Okay, let me share the questions. Okay, you guys see the question, and then we'll start solving the problem. Okay, so what I will do is, okay, after this electronics, okay, in Slack workspace, I'll tell you what topic we can discuss next topic. Okay, so that you guys can revise and come. Am I right? Speak up. So today I couldn't send the message, okay, of what topic I'm going to discuss. Okay, we'll do it from tomorrow. Okay, speak up. So now I will go to next type question. Okay, speak up. I'll pick I mean, regarding diode. Okay, you should be able to handle different situations. Am I right? So there is one question. This is not CSIR, and it may be just or other question. Okay, speak up. So two diodes D1, D2, okay, with threshold voltages 0.7 volt and 0.3 volt. Okay, D1 have threshold voltage 0.7 volt. This is 0.3 volt. I mean, you should know this concept. That's why I'm picking this question. Okay, speak up. Considering the simplified diode model, which assumes diode IV characteristic like this. Can you see here? Okay, forward characteristic. Okay, if this is threshold voltage, at that threshold voltage it is going like this. Okay, speak up. That VTH, that is 0.7 volt for D1 diode, that is 0.3 volt for what you call this D2 diode. Okay, speak up. And you can see 10 volt battery is connected here. What is asking? Current through the resistor. So when you switch on this battery, okay, let me just redraw this circuit. Okay, can I just draw this circuit like this? Okay, this is 10 volt battery. I'll redraw the circuit. Okay, I mean, this is 10, the positive terminal of the battery connected here, negative terminal here. Am I right? Can I make it like this? Fine. Is that okay? That's the meaning of the circuit. Okay, speak up. So that means here I have two diodes here which are connected in parallel. Okay, which are connected in parallel. When you look into that one, it looks like both of them are forward biased. Am I right? Speak up. This is 10 volt battery. What is this resistance? That is 100K. Okay, 100 kilo ohm resistance. Okay, speak up. So D1 here, D2 here. Fine. So, but I mean D1, okay, that threshold voltage is 0.7 volt, but D2 threshold voltage is 0.3 volt only. Okay, now let us see like this. Okay, so there is one switch here. Okay, you just switched it on. When you switch it on, let us assume that this battery voltage rises from 0 to 10 volt. Am I right? Can I say like this? When you switch on, this battery voltage rises from 0 to 10 volt. While it is rising, look at here, D2 will forward bias first before D1, isn't it? Look into this forward characteristic, okay, speak up, of both of these diodes, okay, speak up. If suppose this is for D2, okay, this is for D1, am I right? This is for D1. Can I say like this? I mean, I have exaggerated here. This is suppose 0.3 volt, okay, this is 0.7 volt. Can I say like this? Speak up. So now look at here. I mean, let us assume that when I close the switch or when I switch on the battery, okay, speak up. So this D2 will forward bias first, isn't it? I mean, it will sufficiently forward bias and it will go to its on state, okay, where it is acting like a 0.3 volt battery, isn't it? Are you getting this idea? Speak up. It will act like a 0.3 volt battery like this, okay? Once it is acting like a 0.3 volt battery, okay, it will restrict potential difference across D1 to 0.3 volt only. Suppose, I mean, even though if you increase this 10 volt battery, okay, what will happen? More and more current may flow here, isn't it? In this path. Since it forward bias first, okay, speak up. Since its threshold voltage is 0.3 volt, I mean, it will restrict voltage across this D1 to 0.3 volt. It won't allow it to increase. So then that D1, okay, speak up. At this point, that D1, okay, it is not sufficiently forward bias. It is acting like a open circuit. Are you getting a point? I mean, it need potential difference greater than 0.7 volt to go to on state. Am I right? Speak up. Now, don't ever draw this equivalent circuit. I mean, what you may feel is, suppose this is 0.7 volt, this is 0.3 volt. How a parallel, what you call, elements can have different voltage? That's not possible. Okay, it won't happen. Okay, this will not be sufficiently forward biased at all. Okay, it will be in, speak up, off state. Okay, D1 is in off state. Okay, so this is D2. Okay, that is in on state, and this is the equivalent circuit. Speak up. Then if you apply Kirchhoff voltage law, current I here, fine. What is this one? 10 volt minus 0.3 volt minus I into 100K. Okay, that's equal to 0. I is equal to, what is this one? 9.7 divided by 100K. What is this one? 97 micro amps. Fine. I mean, this is another type of question, okay? I mean, didn't appear in CSIR, but I mean, I want you to know this one, okay? I mean, regarding diode, okay? Speak up. So other circuits are quite simple, okay? I mean, on diodes and all, okay? But this was quite conceptual, actually. I mean, you should think, okay? It will forward bias, then it will restrict the voltage across D2 to point, what you call, 3 volt. So that's why, I mean, it will not be sufficiently forward bias. Okay, I mean, this green, I mean, in the green region, okay, this D1 that is somewhere here, that is off. Is that okay? Speak up. Fine. Now, next thing is, along with the diode, okay, they can give some what is that battery usually. Okay, clipper, clamper circuit. Okay, speak up. Give me a minute. So where is it? Can you see this one? I think I may need to redraw the circuit. It may not be clear here. Fine. Anyway, we shall analyze. Okay. A sinusoidal voltage having a peak value Vp is an input to following circuit. Okay. Speak up. In which the DC voltage, what it is showing? Vp. Okay. Speak up. So peak to peak voltage Vp like this. Okay. Speak up. Assuming that ideal diode means, I mean, when it is forward bias, you can take it as a short. Okay, not 0.7 volt battery. If they mention silicon diode, I mean, look at here. In the previous question, they mentioned silicon diode. They didn't mention. I mean, even though they are not mentioning this part that you take it as 0.7 volt, you should take it as 0.7 volt. Okay, when they mention silicon diode. Okay, speak up. Yeah. So now look into this one. Assuming an ideal diode, which of the following best describe the output waveform? We shall do that one. Okay. So shall I redraw the circuit? That's better. Speak up. One resistor here, D here, VB here. Let me analyze in one circuit only. Okay, just drawing, redrawing, and all. Okay, speak up. He is expecting output voltage, isn't it? Input voltage R here, diode here, VP. Am I right? What he gave? No. VB. He gave VB here. Speak up. This is the circuit. This is the output. Fine. Speak up. And this is the sinusoidal input with peak to peak voltage VP. Sinusoidal, okay, with the peak to peak voltage VP here. Let me draw one by one like this. VI, V out. Okay, that's better, isn't it? VI here. So it is sinusoidal like this. Okay. Wait a second. It is sinusoidal like this. Okay, speak up. I need to find what is the output. Okay, so ideal diode should be considered here. Fine, speak up. So this battery, okay, is trying to make this one reverse bias. You can see here. This is P region. Speak up. This is P region. This is N region. Am I right? This battery is trying to make it reverse bias. I mean, or so I mean, suppose this is forward bias. I mean, so this is positive half cycle. This is positive with respect to this one. This battery is trying to push the current in this direction, but this battery is trying to push the current in this direction. Am I right? This battery is trying to make it reverse bias. Okay, speak up. Now, suppose if VI is less than VB, what will happen? This VI, okay, it is positive half cycle, but it is less than VB. This VB will win actually. VB will win means it will be reverse bias. Okay, in that case, output is when it is reverse bias. Okay, when VI is what you call less than VB. Okay, I mean this VB will win. This battery will win. That means this battery is trying to make it reverse bias. You can see here, N region is connected to positive. Okay, speak up. So then what will happen is diode act like open. Okay, speak up. If diode act like open, I mean if there is no diode here, then what is the output voltage? It follows VI. Look at here. I mean if there is no current here, okay, I will be 0. Current through the resistor is 0. Okay. If current through the resistor is 0, this potential is same as this potential. This potential is same as this potential. Output is equal to input. Okay, when VI is less than VB. Can I say like this? Speak up. When VI is less than VB. Output follows the input. Let us take, suppose so this VB is somewhere here. Okay, he took like that. Okay, this VB is somewhere here. Fine. Speak up. So I mean until when VI is less than VB, it will follow that one. Okay, speak up. If you have VB here, okay, it will follow that one, isn't it? 0 to VB, okay, output will follow the input. Fine. Speak up. Now let me do everything here itself. When VI is greater than VB, what will happen? Speak up. Now, if VI is greater than VB, now this battery will what you call dominate. Am I right? I mean this battery, speak up, will make it sufficiently forward bias. Okay, speak up. So when it is forward bias, okay, speak up. Current will flow in the circuit. Okay, when it is forward bias, okay, ideal diode idea. Okay, it is acting like a short. Okay, once it is acting like a short, speak up. What is output? output will be at VB, isn't it? You can see here, once it is acting like a short, this battery will go here, isn't it? Speak up. Fine. So that's why it will stay at VB. Okay, speak up. Fine, until this time. Then again it will drop back to 0 from here to here. When Vi is less than VB, speak up. It will just follow the input. Fine. So now shall we go to reverse bias? Sorry, what is that? Negative half cycle. Speak up. Negative half cycle. What is this one? Negative with respect to this one. Fine. This is P. This is N. Isn't it? Now see this one carefully. Now this is negative. That means this is trying to push the current in this direction. This battery is also trying to push the current in this direction. Both batteries are trying to make it reverse bias. Isn't it? I mean, it is already connected to N, am I right? P is connected to negative actually. Okay? It is reverse bias. It is reverse bias means? Reverse bias means? Okay? I mean, negative half cycle. Okay? Negative half cycle. Reverse bias means it is acting like a open here. Okay? I mean, suppose for those who don't know the idea, okay, I mean, whenever you have, why we made diode symbol like this arrow, am I right? I mean, if external circuit, if it is trying to set up current in this direction, and if it is sufficient, I mean, if it is sufficiently pushing the current, then it will be forward bias. I mean, you have to think like this, okay? I mean, this arrow direction, okay, in the diode, that means like that. Okay, if external circuit, if it is trying to set up the current in the opposite of this arrow direction, okay, speak up, then it will be reverse bias. Okay, I mean, that's why, I mean, diode symbol, that they made it as arrow. It's quite easy when it is in the circuit. It's quite easy to analyze actually. Okay, now look at here. So diode arrow is like this, am I right? But these batteries are trying to set up current opposite to that one, and you can quickly realize that. Speak up. It is. Speak up. It is reverse bias. It is acting like open. Once it is acting like open, okay, no current in the resistor, no potential drop here. This plus this terminal, okay, can I say like this? Okay, V naught. This terminal and this terminal are at the same potential. This terminal and this terminal are at the same potential. Output follows the input. Fine. Output follows the input like this. Okay, goes like this. So on that basis, you just judge it. Okay, speak up. So when this battery is there, okay, speak up. I mean, remember. So what I did is, I mean, when it is forward bias, it is completely short. No, not like that. Okay, speak up. So when it is forward bias, when it dominates this battery, then only that diode will. I mean, during positive half cycle. Okay, during positive half cycle of the input. Okay, so when the input dominates this battery, okay, then only diode will act like a short. Okay, speak up. When diode act like a short, output will be at VB. Okay, otherwise output will follow the input. Fine, speak up. So try to analyze it again. I mean, you can find this kind of question in the Boyle State textbook. Okay, what is that? This one. Fine. Yeah, it will follow the input in this region. Okay, speak up. Like this. Why you need to draw that level is, okay, what is this? We call reference level. Okay, speak up. Above this level, speak up. Diode is diode is diode is on. Diode is on. Am I right? Below this level, diode is off. Fine. Speak up. And that's very easy. Okay, when diode is on, okay, it is acting like a short. Output is at VB. When diode is off, output is following the input. Okay, that's why this reference, drawing the reference, is the important part in this kind of problem. Fine, speak up. So Boyle State textbook, okay, he mentioned some more problem, okay, and grab the idea about the diode. Fine, speak up. I mean, there are much more question. I didn't find many question on Gina diode in CSIR net, okay, but still you better to have a short practice, okay, speak up on Gina diode. I mean, to be in the safer side, okay, speak up. There is one question, okay, in the previous paper, but it is not utilizing. I mean, it's not any voltage regulator circuit, okay, as a Gina diode, okay. It was that exactly the Boyle state question only. I'll pick it tomorrow. Okay, quite challenging to what you call discuss. I don't know whether you remember or not. Okay, one Gina diode is there here. Okay, then one more diode somewhere he connected somewhere here. Do you remember? He gave one resistor. Okay, he gave one system here like that. Okay, speaker. So quite challenging to analyze this one, but I mean options can be eliminated in the exam question because we have four options. Okay, not a big deal. Okay, but I will pick it tomorrow. Okay, speak up. I feel that's a next level question. Okay, these are one simple level question. Okay, speak up. Simple or moderate, you can think like this. Fine. Any question? Speak up. Draw the reference level. I mean he gives actually one algorithm in Boyle state. Okay, above the reference level, diode is on, diode is off, do like this, then output is very simple to draw. Okay, speak up. Yeah, now what I will do is, okay, I'll pick we have more op amp problem actually. Okay, in CSIR net question paper, I'll pick some op amp problems. Okay, speak up. Starting from the simple. Suppose this one. Okay, the circuit below. Fine. What kind of circuit it is? That's a non-inverting amplifier simply, isn't it? You can see here, this is non-inverting terminal where you gave V in, VI, isn't it? So negative feedback here, you can see here. I mean, let me redraw circuit in my way, okay? I mean, I prefer seeing the circuit like this, okay? I mean, even though they draw this much, okay, if you can, I mean, see that it's a just simple non-inverting amplifier, okay, it's done actually. R1, R2 here. Can you see here? From inverting terminal, R2 is grounded. From inverting terminal, one output. Okay, from output, one load resistor. Okay, I mean, they may try to confuse you by redrawing the circuit. Okay, speak up. You should be careful. Fine. I mean, it is powered up here. Okay, this op amp. Is that okay? Vi is equal to 2 volt. This is 2 volt. Okay, speak up. R2 is equal to, speak up. R2 is 2 kilo ohm. Okay, R1 is, R1 is to be found, I think. Am I right? Value of R1, so that what you call value of R1 required to deliver 10 milliwatt power across RL. Okay, RL is given. RL is equal to 10 kilo ohm. Okay, RL is also given. Fine. What is output? I mean, what is your formula? Output by input is equal to closed loop gain. We say like this. Am I right? That's equal to 1 plus feedback resistor. I mean, we used to write RF by R1 in our symbol. Okay. So feedback resistance, that is R1 here. So divided by this resistance. Okay. That is R2 here. Fine. I mean, I'll write like this. This is a feedback resistor divided by this resistor. Okay. Speaker. What is this one? I mean, I have to keep it as it is, isn't it? I have to keep it as it is. What he gave? He gave 10 milliwatt power is delivered across RL. Am I right? Speaker. So that means So power across that load resistor, that's equal to 10 milliwatt. Okay. Now, how do you write that power? Can you write power in terms of voltage and resistance? How do you write? How do you write power in terms of voltage and resistance? Quickly. V square by R. Can I write this is V naught square divided by RL, that's equal to 10 milliwatt? Fine. V naught square by RL. Okay. V naught is the output voltage. Okay. So from this one, what you can find? You can find V naught. V naught is equal to, so 10 milli into RL is 10 kilo, isn't it? V naught square. What is this one? 100. Okay, speak up. That's why V naught is nothing but 10 volt simply. Fine. If V naught is 10 volt from this formula, okay, speak up. So V naught is 10 volt. Okay, Vi is 2 volt. Am I right? V naught is 10 volt. Vi is 2 volt. That's right. Okay. Then that's equal to 1 plus what is R1? R1 is to be found. R2 is, what was R2? 2 kilo ohm. Okay. 2 kilo ohm. Okay. This is 5 minus 1. Okay. That's equal to R1 divided by 2 kilo ohm. R1 is nothing but what is this one? 8 kilo ohm. Fine. I mean, they just made it slightly not straightforward. Speak up. Not so straightforward. Okay, speak up. Slightly. I mean, they just what you call, they didn't give V naught. They but V naught is mentioned indirectly here. V naught is mentioned indirectly. Am I right? I mean, to have this much V naught, what must be R1? That's what he's asking. Okay, speak up. So that's why, I mean, you can just follow this formula. I don't think this is much big deal. Okay, speak up. Very simple. Write down you. I mean, okay. I wrote this formula. Okay, when I wrote this formula, I found that R1 is to be found. Okay, in the problem. Then okay, Vi is known. Okay, if R1 is to be found, I mean, V naught should be there. Am I right? In the question. That's what he's asking. Am I right? He gave power delivered across the load register. I mean, according to power delivered. Okay, from power delivered, you can grab V naught. Okay, to have that much V naught, what is R1 required? I just found. Okay, speaker. Like that, write down the formula and think, you'll somehow figure out. Okay, speaker. And there is one more type of question that it may appear. So that is, actually this is TIFR question. I mean, but I'm expecting you to know this idea. Okay, now this idea means, okay, look at here. This is also kind of non-inverting only. Because I mean, not directly, because this Vin is given to non-inverting terminal, feedback here and all, isn't it? Speaker. So let me tell you one technique here. Okay, I mean, you can solve in the ideal way. Okay, but what I'm suggesting here is, okay, so now you find what is, I mean, look at here, current into the op amp is nearly zero. Am I right? This I plus, that is nearly equal to zero. Am I right? So that's why this V in 1 kilo ohm, 5 kilo ohm, you have a circuit here actually. Current nearly goes here. So with that idea, okay, with this one detached from the op amp, okay, this is V in here, okay, speak up. And this is what is that? Suppose this one I'll take it as V plus, okay, speak up. This is 5 kilo ohm, fine. 5 kilo ohm, this is 1 kilo ohm. Okay, you find this V plus using this circuit. Why I have detached from this one? Because this current is nearly zero. I mean, for practical analysis, you can detach it. Okay, speak up. And you find this V plus. Is that okay? Speak up. After finding this V plus, okay, when you see the circuit, okay, look into this one. After finding V plus, okay, when you look into the circuit, you know what is this V plus, okay. So, and this is usual negative feedback here, am I right? This is your V naught, am I right? What is this one? This is RF, okay. This is 2K here. Fine. After you find V plus, when you see the circuit, if you are giving the source here, what is this one? Speak up. This is your non-inverting amplifier, isn't it? So what should be the output in this case? Speak up. Output by input in this case, okay. Output divided by what is the input? That is V plus here, okay. That's equal to 1 plus RF by R1. But this is not the gain. This is output by this V plus. Am I right? What is the actual gain? Speak up. What is the actual gain? Output by input is the actual gain. Okay. V naught by V in is the actual gain that he gave us. Okay. That should be 6. Am I right? At what value of this RF, okay, the gain is 6 actually. I mean, he gave this one. Output, I mean, you have to see this whole circuit as some amplifier or something. You gave the input, you took the output, okay, pick up. That ratio is the gain actually, okay. But what you know is, okay, so when you see this circuit like this, okay, if you know what is V plus, you know what is the formula, am I right? Speak up. This is your, what is that? Non-inverting amplifier formula. Output divided by whatever you are feeding here. So that is 1 plus RF by R1. Fine. R1 is 2K here. Okay, speak up. 1 plus RF by R1 is 2 kilo ohm here, isn't it? I mean, this one I took it as R1. Okay, speak up. Usual symbol. So now, speak up. What you have? You just find this V plus in terms of V in. Okay, can you do that one? What is this V plus? This is a voltage divider formula now. Or you can even apply Kirchhoff voltage law also. Or V plus is nothing but potential drop across 5 kilo ohm. Okay, I'll apply voltage divider formula. V plus minus ground, potential difference across 5 kilo ohm. That's equal to, speak up, main voltage V in multiplied with 5 kilo ohm divided by sum of resistors. Am I right? 5K plus 6K. What is this one? Sorry, 5K plus 1K here. What is this one? 5 by 6 into V in. This kilo will get cancelled. Okay, 5 by 6 into V in. Okay, V plus is nothing but 5 by 6 into V in. Okay, just substitute here. V naught divided by what is V plus? 5 by 6 into V in. That's equal to 1 plus, okay, RF by R1 is 2 kilo ohm. Okay, speak up. RF to be found. What else is given? V naught by V in is given. Okay, I mean, to have that much gain of 6, am I right? What he gave? Speak up. To have that much gain, okay, to provide the gain of 6, okay, speak up. What is this one? V naught by V in, okay, that's equal to, can I write 5 by 6 times, okay, or I mean, I can just rewrite here 6 by 5, okay, into V naught by V in, am I right? That's equal to 1 plus RF by 2 kilo ohm. What I can write? V naught by V in also 6, am I right? Speak up. 6 into 6 divided by 5, that's equal to 1 plus RF by 2 kilo ohm. Can you quickly solve it for RF here? 36 by 5, okay. RF is equal to 2 kilo ohm multiplied with, okay, 36 by 5 minus 1. Can I write like this? 36 by 5 minus 1 multiplied with 2 kilo ohm. What is that value? 12.4. 12.4 kilo ohm. 12.4 kilo ohm. Okay, that's the right option. Now, I mean, why I picked this question? Because I mean, usually the basic idea is, okay, you need to find V minus, okay, you need to find V plus, okay, you need to do this one, okay, V plus nearly equal to V minus, okay, for any negative feedback circuit, okay. I mean, if you take that open loop gain very high, this is actually closed loop gain. Whatever the gain 6 is talking about, that is closed loop gain. Okay, whenever he say open loop gain is very high, speak up. Look at here. I mean, that open loop gain is infinity. I mean, assuming that open loop gain infinity, that is mathematically equivalent to V plus nearly equal to V minus. That's how we need to do problem. Okay, we should find V plus, we should find V minus again by assuming current into the op-amp is nearly zero by applying Kirchhoff voltage law here. We need to equate them. In that equation, everything will be there. Okay, speak up. But what I did is, I mean, I want to save some time here because I know what is the formula for what is that non-inverting amplifier. So that's why, okay, I mean, if you have non-inverting amplifier like I took here, okay, what is the output? 1 plus Rf by R1 times Vi, am I right? 1 plus feedback resistor divided by this resistor times whatever the voltage that you are feeding. Okay, I'm doing the same thing here. Is that okay? I'm applying the same formula. This V naught divided by whatever you are feeding here, that is your non-inverting amplifier formula. I'll make use of that one to simplify the step. Okay, to save some time. Can you do this one? Speak up. Now, what I'm saying is, whatever the complex, I mean, this is like this. Suppose the trick here is V naught here, okay, plus here. So here, whatever the network he gave here, he may give some network here, battery, register, or something. Okay, what you have to do? You find what is this V plus. Suppose if it is RF, if it is R1, okay, then V naught by V plus whatever you are feeding here, okay, that's nothing but, speak up, 1 plus RF by R1. Are you getting my point? Speak up. That V plus, I mean, in case of suppose if you take a non-inverting amplifier, you give this one as V in, am I right? Pick up. You give it to some battery, I mean some source, okay, sinusoidal source or some variable source. Now that V plus was equal to V in actually. Okay, speak up. But what they may do, I mean, in this case, V plus is nothing but V in. This is the usual V in here. Okay. What they can do, they can give some network, then they can feed it to non-inverting terminal. Okay. Then you just find V plus, you use the same formula. That's quite quick. Okay. Speak up. Fine. Speak up. So otherwise, I mean, the main idea is, okay, if you have a negative feedback, okay, speak up, plus here, minus here. Okay. So let me take something here. Here you may have battery. Okay. Here you may have battery. Okay. So, but if you have a negative feedback, okay, speak of V naught. Here you may have any network here. Okay, speak up. In such case, what is the main idea? I mean, if suppose open loop gain is too high, open loop gain means when you have no feedback. If it is too high, okay, speak up. That open loop gain, assuming that open loop gain is infinity, that is mathematically equivalent to assuming V plus nearly equal to V minus. That means you find this V plus, you find this V minus, speak up. That V minus contains V naught. I mean, assumption is again current into the op amp is 0. Okay, speak up. By assuming that one, I mean, if you apply Kirchhoff voltage law here, I mean, that Kirchhoff voltage law contains V naught. Am I right? V minus contain V naught. Somehow you will have input and output link in this equation. Are you getting my point? Speak up. So, I mean, this is, I think, called as golden rule. Speak up. Fine. This particular condition. Okay, V plus nearly equal to V minus only for negative feedback. Don't apply this one for positive feedback. Okay, speak up. Yeah, let me pick one more problem. What you need to practice here is, okay, in case of op-amp circuit, what you need to practice here is, okay, I mean, I didn't solve any of this problem, okay, speak up. I just picked it up, okay. I mean, but I mean, when you see the problem, you should be able to quickly think and solve, okay, speak up. So what is this one? This is kind of, I mean, sources are given here, inverting type, am I right? Speak up. Then how do you do? I mean, what you need to practice in op-amp circuit, that's what I'm thinking, okay, speak up. Again, this V plus, am I right? This is V plus, this is V minus, am I right? Again, you apply that idea, V plus nearly equal to V minus. What is V plus? V plus is grounded. That means V minus is also 0 volt. We call this means virtual ground concept. Am I right? I mean, if one is grounded, other also virtually acting like a ground. Okay, speaker. Okay, from this idea, how to what you call get whatever he's asking. Consider a circuit and all. Find the output voltage. He's asking output voltage. Fine, speaker. Now look into this one. Okay, again the same idea. Current into the op amp is 0. So that's why whatever current develops here, okay, speak up. Whatever current develops here, that current should go to feedback circuit only. Isn't it? Are you getting that idea? Whatever current develops here, that should go to feedback circuit only. Fine? Speak up. So that's why, I mean, if I take this one, I mean, let us assume like this, okay? I mean, okay, in the feedback circuit, actually, output is, let us see, this is plus 12 volt, this is minus 12 volt, R and 4R, am I right? So can I take current like this, I1 here? Then what should I do? Should I take current like this here? This is 0 volt. Plus 12 volt. I mean, what I will do is, okay, speak up. I'll take I1, I2, I3, okay? But I3 is actually opposite of whatever actual current, okay? I mean, this works actually, okay? This idea works, okay? Because this is negative anyway, I mean, it will be taken care, okay? That I1 plus I2 plus I3, that's nothing but, can I say, feedback current? Look into this one. I1 plus I2 plus I3, that's equal to IF, because these all current, it should go to feedback path only. Okay, because current into the op amp, current taken by the op amp is nearly 0. Okay, speak up. You apply this idea. Okay, I mean, there are many problems like that. That's why I picked this one. Okay, speak up. Now, what is I1? I1 is nothing but, okay, so this potential minus this potential divided by this resistance. I2 is nothing but this potential minus this potential divided by this resistance. I mean, since I took I3 in this direction, again this potential minus this potential divided by this resistance. Okay, what is this one? Plus 12 minus this potential is 0 volt. Okay, minus 0, 12 minus 0 divided by R, plus I2 is nothing but 0 minus 0 divided by 2R, plus minus 12 minus 0 divided by 4R. Are you getting fine? Speak up. Minus 12 minus 0. I mean, it will take care. Look at here. It itself is saying that I3 is negative. Am I right? I mean, it will take care. Okay. Now, IF. What is IF? Speak up. V naught. Okay. What is this one? This is 0. I mean, if I took IF in this direction, means, look at here, I'm assuming this is higher potential, this is lower potential. Am I right? Speak up. I mean, whenever, if you have a resistance, okay, this is the idea that I'm applying. If you have a current here, if you have a resistor here, okay, speak up. Suppose I'll take this one as VA I'll take this one as VB. Fine. Speak up. Now the equation is, what is this one? Assumption is current is flowing from higher potential to lower potential. Okay, higher potential minus lower potential, that's the potential difference, that's equal to I into R. Okay, our current is nothing but higher potential minus lower potential divided by R. Is that okay? This is the idea that I am applying here. If I have on the register, if current flows from this terminal to this terminal, if my assumption is like this, okay, so then speak up. This one minus this one divided by this resistor, that's equal to current. I'm applying the same thing, okay? 0 volt minus V naught. Am I right? 0 minus V naught divided by what is this one? R. R is common over there. R will get cancelled here. Okay, what is this one? 12 by R minus 12 by 4R, that's equal to minus V naught by R. Can you quickly find? Minus V naught is equal to 12 minus, what is this one? 12 by 4, 3. V naught is equal to minus 9. Fine. Speak up. I'm expecting you to what you call practice this up. Okay. I mean, everywhere, okay, I have applied this idea. Okay, what is that one? Current is equal to, okay, I mean, if current is flowing in this direction, this side potential minus this side potential divided by resistance. Okay, speak up. And those three current, okay, this I1 plus I2 plus I3, they should add up, should be equal to IF. Why? Current into the op amp is nearly 0. Fine. So grab this idea. Speak up. I think so. Let us close it for today. Okay. So you guys join. I mean, any new student on YouTube. So join. I think you can do this one. Okay. I mean, very simple. Okay. I'm just simple to moderate question. I will just keep it here. Okay. Try this up. Again, one inverting amplifier. Nothing much big. I think you can try to answer this question also. Why we use that voltage follower circuit? Am I right? If output is same as input, okay, this circuit of op amp, it's called as voltage follower, isn't it? What is this one? Plus minus here, okay, you give V in here, you just short this one. Am I right? V plus is same as V minus. V plus is V in. V minus is same as V naught. V naught is nothing but V in. I mean, in any negative feedback, V plus nearly equal to V minus. This can be used. Okay, speak up. Negative feedback. Okay. If output voltage is same as input voltage, why we need the circuit? I mean, why need this much? I have V in here, some battery. I'll just proceed it with one wire. Why I need op amp? You can design an ideal voltmeter using this kind of circuit. No. What is the very basic idea? So if there is any variation in V in, I mean, that the same variation will be produced here. Okay, speak up. Suppose if this input source is weak, suppose this input source is not capable of producing much current. Is that okay? Speak up. In that case, this is very, very useful. Okay, let us say like this. Okay, you have one what you call information, which is sound. Okay, some variable voltage or something here. Okay, speak up. You are feeding here, but your source is not what you call capable enough to drive many speakers. Can I say like this? If you wish to drive many speakers, I mean, then more current will be drawn from the source. Am I right? Speak up. You have some what you call your output of your amplifier, suppose, but it cannot give you much current. Let us say like this. Okay, suppose if you want to drive many speakers, okay, then what you can do, you give that input here. Op amp takes nearly nothing from the source. Okay, but the same variation will be produced here, and output you can draw any current in the output of the op amp. Is that okay? Speak up. You can draw any amount of current in the output actually. I mean, output of the op amp, okay, speak up. It will give you more current actually. Okay, I mean, it is acting like ideal voltage source actually. Okay, speak up. Without what you call having any changes this voltage, it can drive many circuits. We say like this. Okay, when your source is weak, you can use this one, or you can use this one in a voltmeter. Okay, if you use this one in a voltmeter, that voltmeter, I mean, op amp internal resistance is, I mean, nearly very high. Am I right? I mean, this input resistance, that input resistance will be added to your voltmeter. Voltmeter resistance is high, means it's a very good voltmeter. Am I right? It can be used in a voltmeter also. Okay, so this question is designed on that basis only. Okay, you have two circuit here. uh, Speak up. What is the role of this A1? Like that he designed the question. Is that okay? What is the role of that A1? That's what he is asking. Fine. Speak up. Try to answer that question. Okay. Speak up. So let us close it for today. So tomorrow, okay, again I'm going to pick difficult question on this topic. Difficult, challenging question which may consume some time to convince. Okay. I'll pick those questions. Okay, speak up. And I'll pick couple of transistor question also. On transistor also, I will just keep very basic questions. Okay, like finding current, IB. So tomorrow I'll solve some basic transistor question, and then I will move on to challenging questions. Okay, speak up. Fine. I'll keep this transistor questions. Okay. I mean, if I look into the problem once, okay, before starting the class, then I can solve more problem in the class. But I mean, it's my practice that, I mean, if any new ideas can be generated in the at that instant of time, okay, when we have no time, usually, okay, we'll try to solve problem in less time. Am I right? Speak up. So that's it. Those are very basic transistor related question. Okay. And in op amp, that integrator differentiator is a usual question that they are asking, that I hope, I mean, if you have just studied that one, it's not a big deal to solve that one. Okay, what is this one, integrator or differentiator? I told you some mnemonics to remember. Am I right? Integrator or differentiator? How do you say differentiator? I mean, the mnemonics that I remember, if you have a capacitor in the input, that will differentiate. Okay, like that I remember. The square pulse, it's, if you differentiate, you will get spikes actually, isn't it? Because it will have a very high change at that point, infinite slope or something, you can think like that. Okay, it will give the spike. I mean, look at here. I mean, options he didn't care much. Spikes, isn't it? You can quickly choose the options. Okay, you just have to observe that this is a differentiator, output is a differentiation of input. Okay, this problem also you can solve. Okay, regarding basic op amp question, basic transistor questions. Okay, basic transistor question. Now tomorrow I'll come out with challenging question. Okay, we shall have 1.5 hour session. Okay, tomorrow. So in the transistor, I am expecting you to solve this problem first. Okay, wait a second. Let me keep it here. Solve this problem first. What is that? It's also CSIR net question only. Two circuits are given. Which one is in active region? Which one is in saturation region? That CE configuration. Okay, DC biasing. If you solve this one, if you solve this one, okay, then that is the basic idea about op amp CE configuration biasing. Am I right? I mean, whether our biasing will drive it to saturation, cutoff, or active region. Okay, you start with this one. Okay, speak up. Most of the question, I think these questions are assuming that it is in active region you are going to calculate. Okay, not, yeah, active region. Am I right? active region. Okay, speak up. So, but I mean, you better to start with this problem. Okay, speak up. I'll solve this transistor question. Okay, then I'm going to proceed. Okay, speak up. Yeah. Any question? Okay, let me pick up that. Yeah. Are you guys? Can you are you there on Google Meet? Speak up. Someone is asking question. I mean, name is not mentioned. Can I ask your name, Tom? I gave 5 attempts in exam. I'm not qualified or something. If you explain a little bit, I can answer your question. I mean, how did you prepare? Which material you took like that? Are you there? No, no. I mean, look at here. Telegram material. Just by having some material, you do one thing. You just go through our method of learning once. Okay, speak up. A material should be after learning stage. Okay, speak up. Whatever material you choose, that is good actually. Okay, suppose you pick one IITN. Okay, you give him any material, he will crack this exam. Can you tell us why? Because he already learned. I mean, his conceptual understandings are good. I mean, his basic, even he has enough problem solving skill. You give any material, okay, they will crack the exam. They will say this material is good. Okay, speak up. That material should come after material or MCQ, whatever. I mean, formula. You try to recall formula, you apply the formula. It should come after learning process. Okay, because exams are becoming more and more competitive. Okay, year by year it is more and more competitive. Okay, speak up. They are designing more and more deep question. Okay, more and more conceptual question. Today these questions I picked, these are easy to moderate. Okay, challenging questions are still there. Okay, let me pick so tomorrow. Okay, each question may require 15-20 minute discussion actually. Okay, speak up. So that's why, so that learning phase should happen. Okay, after that material phase, exam, I mean, orienting whatever you know, I mean, orienting that one towards exam. Okay, both can be done together, learning with what you call having some practice problem and all. Okay, so but I mean, if you start with a material, if you haven't learned it, okay, I don't think you will survive in this level competition. Okay, I mean, when we see this gate question with this CSIR net question and all, I mean, they are becoming highly I mean, I feel I was very fortunate. Now I can solve any problem because of experience. At the time when I was writing the exam in 2016, there was very what you call less competition compared to right now actually. Okay, I mean, since I'm in the same field, I can solve any problem now. That's a different story. Okay, at that time there was very less competition. Okay, cutoffs were also less actually. Questions were also many easy questions used to be there. Since competition is more, they are asking more and more difficult question, more and more deep question. So that's why I don't think without learning phase, okay, that learning will not happen with any material. Okay, you should have a patience. You have to sit with one textbook, any standard textbook you take. Okay, you just go through the our reference textbook page, okay, in our website. Okay, any what you call reference textbook. Okay, if you sit with that one and if you solve those example problem, you will get a complete idea regarding that topic, so that you can apply that idea to solve the problem. Okay, try to understand this whole philosophy. Okay, so then that's the first thing. Then you have to pick the material, or you keep the material parallelly. Okay, learning cannot be skipped here. Okay, speaker, I mean, today I solved op amp and diode problem. That learning, whatever I solved, that learning happened with that boil state textbook. That's why I'm solving any problem, I'm applying that one, whatever I have learned. Okay, learning will happen with the standard textbooks. Okay, pick a standard textbook, have patience. Okay, or use some YouTube resources or something. Okay, so try to understand that one. So then solve that some solved example problem in the standard textbook. Suppose if you feel outside problems are difficult, After that you go to multiple choice question or any material, any formula based material that looks good actually. Okay, then you will be capable of solving any new question. Okay, speak up, wait a second. So that's why, I mean, whether you join our course or not, that doesn't matter, but the method is very ideal. You just follow this method. Okay, speak up. And one thing, that's one part. Okay, I mean, if you are capable, you just follow our method one more time and give an attempt. Is that okay? Hmm. Syllabus is completed. Some he's replying like syllabus is completed means, now look at here. If you have understood well in GATE exam, okay, in one exam you made some mess, you did some mistakes and all. No, in at least in other GATE exam, if your conceptual what you call knowledge is good, GATE exam must be somehow cracked actually. Okay, because question they pick the concept, they design the question. Okay, I mean in GATE exam and in JAM exam also. So that's why if your conceptual hold is good, GATE exam should be qualified. But in CSIR net exam sometimes they copy the question from different resources. I mean, it may not be quickly solvable at that instant of time, but in GATE exam every questions are very well designed. Okay, speak up, your conceptual hold should be very good. Okay, so that will happen only with the standard textbook. Okay, I mean, no, not even video lecture. Okay, even if you watch some video lecture, okay, speak up, from that video, okay, if I deliver 100%, you receive maybe 50 to 70%. Is that okay? Speak up. So that's why you should go back to the book, you should sit with that one. Okay, you should spend time with that textbook. Okay, then slowly, I mean, that concept will be digested. You have to solve the problem that they give. Whatever the chapter they give, okay, they give one concept, they give one example problem. Why they give example problem? Because okay, you learned something, you have to now check whether you can apply it or not. While applying, you have to check whether you have understood it in the right way or not. Am I right? I mean, you may think like you understood it, okay, but while applying, you will get to know what is the missing, isn't it? Speak up. So that's why, I mean, how you completed the syllabus, this CSIR net syllabus, that's important. With only material, if you say you completed the syllabus, I mean, even if you solve thousands of problems with any material, with any formula book, with any solutions, it won't count at all. If you solve thousands of problems by seeing the solution, you can take a zero count in your progress. Is that okay? Speak up. That's why sometimes while doing the course, okay, sometimes quickly, if there is any problem that is posted, I may not able to solve it quickly. Am I right? Time will be up and all. I'll not be worried much. As long as you guys trying yourself, I'm very happy. Because while trying yourself, your mind is working actually. Okay, I mean, your mind is rewiring actually. I'll be happy actually. Later, I'll pick that challenging problem and all. So no, I mean, yeah, that's what he exactly said. He can solve only previous MCQ, not any new MCQ. That's exactly what this material-based preparation lead you to, isn't it? At the end, you can solve only previous question because whole material is built out of previous question. Okay, so you do one thing, you just go through our website. I'll just post the link. Wait a second. I'll just comment one more thing regarding this one. Okay, where is our method? So not only this, look at here. I mean, let me tell you. Okay, some more the realities. Okay, speak up. Just go through our method of learning. Okay, and reference textbook page. So you will get to know. Okay, speak up. What is missing in one's preparation? Okay, speak up. I mean, so without learning phase, you can't go to direct exam preparation phase. That is the main aspect. Okay, that learning will happen with the textbook, with a discussion. Okay, by solving the textbook actually. Okay, not just look at here. When I was in MSc, I was so much interested in the subject. I was reading the theory so much. This Griffith's electrodynamics and all. I worked out a lot of theories. I didn't solve even single problem because in our MSc they used to ask very less problem in the exam. Okay, but when I started preparing for exam, I couldn't solve any exam question, even though I knew the theory. Okay, I worked out even Griffith's electrodynamics theory actually, but I didn't touch even solved problem in between the chapter. Why he gave those problem in between the chapter? Because whatever we understood, we need to apply. While applying, we should correct it. We should rewire it. Okay, whatever we understood, that is right or not, we don't know. While applying, we need to rewire it. Okay, later I sit and solve those problems. Okay, then all rewiring happened. I could able to solve any problem, and many problems were from Griffith's electrodynamics only in exam. Okay, so that's why. So this book learning, I don't think even a chat GPT can replace. Okay, because that author have 30 to 40 year of experience, and they are a theoretical physicist most of the time. They know in depth of that theory. Okay, and they created, it's their creation. Okay, that textbook is their creation out of 40 years of experience actually. I mean, that cannot be replaced actually. Okay, that's why pick a textbook, solve textbook problem, then along with that one you solve previous MCQ, and you should able to solve previous MCQ yourself. "20 register I file." I'm not getting your question. Okay, so this is one part. Okay, other part is, okay, I mean, if you have, I mean, even though you don't have to enroll our course, okay, a lot of course materials are available on the website and YouTube channel. Okay, and you can just follow it and you can re-prepare for next exam. Now look at here. So I mean, you did some ideal preparation. You have learned the physics. Okay, speak up. Suppose you have learned the physics. Okay, speak up. Learning phase is also good actually. Suppose if I quickly throw you one problem from some textbook, if you are capable of solving. Okay, speak up. Learning phase is also finished. Exam orientation, that's also finished. Suppose, I mean, you have solved enough practice test and all. Okay, even after these two, okay, speak up, even after these two, many people when they go to the exam hall, they do some mess and they will come back. Is that okay? Speak up. In the class, even if I throw very new question, they could able to solve. In the exam hall, they will mess up something and they will come. Is that okay? Now look at here. Learning. I mean, if you skip the step, you can't solve any new problem in the exam, and most of the problem will be new problem only. Okay. I mean, if you see large CSIR net paper and all, I mean, problems are not repeating. Very less problems are repeating. Okay, all of these exam strategy videos and all you are seeing, they are on the basis of previous exam. Is that okay? In the next exam, whatever you are going to face in that exam hall, okay, maybe 2 to 3 question may repeat. Will 2 to 3 question qualify you? Are you getting point? Okay, next exam, next CSIR net exam. Suppose 4 questions repeats. 4 concept, the same concept, only data change. 4 question repeat. Will 4 question will make you to qualify the exam? No. You should solve many what you call new problems while applying the concept to previous problem. Okay, after that full rewire, when you are capable of solving new problem, then you are ready for the exam. Otherwise you are not ready for the exam at all. Speak up. Even after you are ready for the exam, I mean, what I have experienced is, okay, they are completely ready. If I throw you one, suppose MIT Princeton question, they will solve in the classroom, but they will go to exam hall and they will mess up because of that fear. They can't handle that pressure, exam hall pressure. I mean, that I'm still working on, how to make them ready for that, I mean, face that exam hall pressure. Because these things I can do with the course, am I right? Because I have time here, isn't it? Or during the exam, when they go to the exam, what they do in the exam hall, why they are getting scared. I mean, because I was not getting scared in my student career in exam hall usually. I mean, I'm still working on that one. Okay, speak up. How to come out of that exam hall fear? Let me try to communicate that one. Okay, I mean, whatever I have some ideas. Okay, I'll communicate this one. Okay, I mean, The idea is you should go to exam hall without any expectation. No, I mean, you have done years of preparation with for exam only. How can you go to exam hall without any expectation? That's quite hard. Anyway, let us keep it away. I mean, so but what I am saying is, okay, even after 2 to 3 attempts, okay, speak up. Suppose if you are not qualifying exam, but if your physics is good, if your problem solving abilities are good, if your thinking abilities are good, not just material preparation, okay, if you have material preparation, you will not have any confidence to pursue next career actually, okay, not by material preparation. Suppose if your preparation is ideal, if your physics is good, okay, understanding is good, problem solving, I mean, if you thrown to some problem, you just collect everything, you start solving the problem. If your approaches are good, even though if you couldn't crack the exam, you should find other way to pursue your career. Because take our course again and again, attempt again, exam again and again, these are coaching industry strategies. Isn't it? Speak up. Hmm? I mean, take it again and again. I mean, pay half pay and join one more batch. These are our strategy. Okay, speak up. Coaching industry strategy. Don't fall into that one. Okay, speak up. If your physics is good, I mean, if your physics is not good, then if exam didn't happen, then you better change the career. Okay, speak up. If your physics is good, if your problem solving ability is also good, if you are able to solve very unique new problem in the classroom, but in the exam hall something is happening, okay, if you couldn't perform well, or you couldn't perform well in, I mean, with first attempt, and suppose if you are running out of money and if you can't again prepare and give one more attempt, in such case you should find alternative way to pursue the same career. Okay, speak up. Not again. What will happen is, okay, you prepare 1 year, okay, freshly after your graduation, okay, you prepare 1 year and you give an attempt, okay, speak up. Usually at that time you will be confident enough. First attempt you will be definitely confident enough. I mean, some people may, what you call, feel that exam pressure, but most of the student will perform well. Okay, if you wait for one more year, that pressure will build in the exam hall. I'm very doubtful whether you can handle that pressure or not every student can handle that pressure. Are you getting a point? Speak up. Suppose, I mean, that's why I was asking everyone to prepare for this exam during graduation, where you don't have any pressure, or at least after graduation you can take a drop year and you can revise, prepare well actually. I mean, you will not have much pressure actually. Handling exam hall pressure is one of the greatest tasks here. Speak up. Because other thing, okay, we can do it slowly. That handling exam hall pressure, it depends on your innate nature actually. I can't quickly mold it actually. Other this learning or approach and all, I can slowly change it actually. So that requires very different mindset. Okay, I can't quickly change it actually. So that's why. So I mean, if you take gap year, okay, or if you take 2 to 3 attempt actually, so what I have observed is, okay, one student, okay, before coming to coaching, okay, before enrolling to coaching, had some gate ranking. Okay, after enrolling to coaching, very happy with the coaching, very good at concept, very good at problem. Okay, ranking decreased. Can you explain why? Because that drop year put more pressure actually. Not drop year, 2 drop years. That put more pressure actually. Are you getting my point? Speak up. I mean, already attempted, okay, once had some gate ranking, wanted to improve gate ranking, learned more, huge physics, okay, and capable of solving any problem. But in the next attempt, even though that gate exam was easier than earlier, ranking got, what you call, slightly worse, not fully worse. Why? Because already spent 1 year after the graduation, okay, and couldn't get good gate ranking, okay, then spent 1 more year, okay, even though physics is good, even though physics is improved, that exam hall pressure is increased, that expectation increased, am I right, from the exam. Okay, so that's why that many students will not handle that exam hall pressure. I'm working on it. Okay, some philosophical part. If I come out with any convincing idea how to handle exam pressure, I'll come out with that one. Okay, before next month. Okay, and one more thing is, I would suggest maximum 2 attempt. Okay, maximum 2 attempt of CSIR net exam. Okay, or if after graduation, if you took drop of 6 months, usually by the June your semester will be end. Am I right? If you take a six month drop and you keep on attempting the exam, okay? TAFR, CSIR net, GATE, just and all. Am I right? After that one, what I strongly suggest is, suppose if you didn't have good result, you should find other way to pursue your career. Okay, you take time and you become competent enough. Okay, again, if you take one more drop here, pressure will build. Even though your physics is good, whether you can handle that pressure or not, that you should think. Is that okay? Speak up. Again, purchase course again and again, enroll course again and again, pay and attempt again and again. I don't think that's a good idea, because we have only, suppose out of this 100% of student population, our premier institution, they will take only 3% or less than 3%. Is that okay? 96% of the students, are they not capable? Many of them are capable. Okay, but our premier institution will take only 97% here. Okay, where 1% went. Anyway, they don't study at all. Speak up. So that article only 3% or less than 3% in this basic science, because we have less graduate institute for basic science. Okay, this data is engineering related together actually. Okay, speak up. Less than 3%, you can take it as 2%. What that 98% of the people should do, isn't it? They have opportunities in the industry, in the field related to physics. They have opportunities. You should find some other way. You should not keep on purchasing some more coaching and keep on doing that one. Okay, speak up. So that's why, with this age, okay, you guys have to be matured enough to understand everything, isn't it? Speak up. So what I suggest you is, suppose if you give many attempts, if you couldn't qualify, if you are financially capable, you try with our learning method once. In that one also, handling exam hall pressure, okay, is the most important part. Even if you go to some counseling with a psychiatrist, that's better, isn't it? You take one more drop year now. Okay, he already said he took 2 drop year from 2020 to 2024. Okay, if you take one more drop year, you need very expert opinion on handling the exam pressure before going to exam. Okay, I feel very good psychiatrists are required. Let me try to do my treatment before this CSIR net exam, my ideas before this CSIR net exam. So now, okay. Now one more thing. What he said is his energy, time, and money is also wasted. Okay, energy will not be wasted. Okay, speak up, isn't it? If you work hard, that hard work is, if it is practiced, okay, that experience will come. Am I right? Speak up. Energy is not kind of waste. Okay, whatever hard work you did, whatever focus you have, with he said he took some material and he prepared. He lost years. Okay, but he had some focus over there. Am I right? He did some material. At least I see that one is positive. Even though his method of preparation is wrong, I feel the focus whatever he had, that is positive. If you have that much focus, you can somehow set your career. That's my belief. Okay, so that's why. So now, okay, now suppose if you don't have money, okay, this, if you don't have money to again purchase our course and do that one, I don't suggest that one now. Okay, speak up. So we kept nearly 20% of our course material on YouTube freely. 20%, go through the playlist, Okay, you can solve 2 chapters of Griffith's quantum mechanics in quantum mechanics. If you solve 2 chapters, you can solve 2 more chapters. That is sufficient for the exam actually. Are you getting point? If you solve 2 more chapters yourself, okay, you are ready for the exam. I mean, many YouTube subscribers, they replied after GATE exam, I mean, I qualified GATE exam because of your YouTube channel. I mean, I didn't believe that one completely because they had something, because only 20% of the materials were there on YouTube. Is that okay? But still, that was enough for them to kickstart that actually. In Griffith's electrodynamics, you can solve 3 chapters: vector calculus, electrostatics, and potential chapter. You can solve 3 chapters. If vector calculus is good, you can solve magnetostatic. I mean, you can go up to that, what is that, Maxwell theory chapter actually, if your vector calculus is good. With our YouTube playlist, okay, so you can solve 3 chapters of Griffith's electrodynamics. Okay, and I mean, this is one more what you call thing to reveal. I think almost all classical statistics can be done with our YouTube playlist. I mean, now those who joined our course, they may feel, okay, this many things can be done with a playlist. Yeah, it can be done. Full of classical statistics, okay, with all problem solving ideas. I mean, from a Reef textbook and many just revision classes where I imparted problem solving ideas actually. Okay, speak up. And along with that one, I mean, if you what you call manage some more, what else is there in our YouTube? Classical mechanics. Full Lagrangian mechanics can be done with our YouTube playlist. YKLM level questions. Speak up. You have these many free resources. Along with that one, you have NPTEL course. Okay, speak up. You have suppose MIT courses, isn't it? With that, I mean, you have sufficient thing. I mean, if you focus, you will definitely do. Is that okay? Speak up. So that's why, I mean, if you are financially capable, you spend, I mean, 6 more months with our learning method, even without enrolling our course, this much you can do. If you solve 2 chapters of Griffiths, you will solve 2 more chapters, isn't it? If you solve classical statics, then you pick some quantum statics, somehow you will understand that quantum statics ideas also with some quantum mechanics input actually. Okay, if you solve Lagrangian mechanics, you will understand Hamiltonian dynamics also. Speak up. So that's why I don't think, I mean, you need to spend any money. You just have to be smart enough. Is that okay? Speak up. And in our website, go through the what you call resources. Okay, topic wise question, all previous topic wise segregated. Okay, and kept as, I mean, you can take it like a practice test only. Is that okay? Speak up. So that's why don't lose hope. Okay, just check whether you can spend one more time or not. If not, don't spend heavy amount on any material purchasing any course. You just make use of our free resources. That's sufficient. Fine. All the best. Anything else? Actually, this is not problem solving. Okay, speak up. Anyway, we'll see. I mean, before this CSIR net exam, I will tell you my idea to handle exam pressure. Okay, speak up. Fine. Yeah, go through our method page, reference textbook page, then go through our resources and check our YouTube playlist. Okay. So thanks for joining this session. We'll meet tomorrow morning at 7. Okay.